Hi everyone, welcome you back in this physics video, and in today's video I'm going to discuss over here the third case of this charged particle motion when it is going to enter at an angle other than 0 degree, 90 degree or 180 degree. So in our previous topics videos which is sent to you, in that we have covered case first and case second. Means 0 degree, that if it is going to enter in the magnetic field, or either at a 90 degree when it enters in the magnetic field. So that motion we have discussed in the previous videos. Now today it is that a charge is going to enter at an angle. Okay, so for this purpose I have considered this is the axis, x-axis, y-axis and z-axis. This I have considered over here. Now magnetic field, let us suppose it is along x-axis and there is a charge plus q and whose mass is m. So it enters at an angle, so its velocity is at an angle with this magnetic field. Okay, so it is making this theta angle. So over here that when it enters at an angle with this magnetic field, therefore we are going to split this velocity into its component for to see that motion of this charged particle in this magnetic field. We are going to split it into two component. So one it is v cos theta while the another is v sin theta. So v cos theta, that this is the base angle, and along this side the component it becomes horizontal v cos theta, while this which is along vertical axis it is v sin theta. So thus we are having over here that this v cos theta is along magnetic field direction, while this v sin theta it is perpendicular to this magnetic field direction. Now let us see over here that how much is the force which is exerted when this component of velocity is along the magnetic field, or either we can say that what will be the magnetic force due to this component of the velocity. Okay, so as we are known that magnetic force is given by qvv sin theta. Okay, this is the formula over there. Now how much is that velocity along this x-axis? So this is v cos theta. So instead of v I will write over there v cos theta. So thus this magnetic force along x-axis, so along x-axis that I'm going to talk about, it is along x-axis. So there we are getting it is qv cos theta b sine. Now how much is the angle between this horizontal component and magnetic field? It is 0 degree, so it becomes sine 0 degree. It means it is 0. So there is no magnetic force. It means over here this v cos theta is constant. So v cos theta is constant. So that means its velocity will not change when it is going along this magnetic field direction. Okay, and there is no magnetic force exerting on it. But over here that this vertical component, so how much is the force going to exert? Is there any force exerted due to of this component? So for this we are looking that this vertical component, it is perpendicular to that magnetic field. Then this is the force on that due to of its vertical component of velocity, we will find that it is q. Now see over here how much is the velocity right now? So it is v sin theta we have to use over here. Okay, so thus it is going to be q v sin theta, and there it is b sine. So sine, that is the angle between this magnetic field and this component of velocity. So this is going to be 90 degree. Okay, thus we get that there is the magnetic force which is exerted, which is equal to qv v sine theta. Okay, this is that magnetic force. Okay, so thus we get over here that under the effect of this that force on this charged particle, it will tends to move in a circular path. So this will move in perpendicular to this magnetic field. Okay, so due to of this magnetic force, that it will move in a circular path, and this circular path is perpendicular to this magnetic field. Okay, so this circular path is perpendicular to that magnetic field. Okay, so just look over here that we will have then its motion which is given over here. So here it is the circular motion which is done by this charged particle, and while it is going in the horizontal direction, so that time it's a v cos theta, that a component of velocity, it remains constant. Okay, so in this way that we are getting this is that motion of that charged particle. Okay, so over here we can see that it is also having this linear motion. It is moving along this horizontal direction, as well as it is moving in this that is circular path. Okay, so thus we are looking over here that this horizontal motion is because of this v cos theta, horizontal velocity, and this vertical motion in the circular path, that is moved due to of this vertical component. So it is the combined and that motion we are looking over here. So thus over here, as we are known that to move in a circular path, centripetal force is required. So over here this magnetic force is providing this necessary centripetal force. ठीक है, तो सर्कुलर पाथ में चलने के लिए कौन सी फोर्स रिक्वायर्ड होती है? सेंट्रीपिटल फोर्स. ठीक है, और ये फोर्स कौन प्रोवाइड कर रहा है उसको? जो ये वर्टिकल कंपोनेंट की वजह से मैग्नेटिक फील्ड लग रही है. ओके, सो हाउ मच इज दिस वन? सो दिस इज ओवर हियर क्यू वी बी साइन थीटा. This is that magnetic force, and which is equal to how much is that centripetal force. So if we are supposing that the radius of this circular path, let it be r, so then it will become m, the component this velocity over here, what with which velocity that it is going to move in this circular path. So it is due to of this v sine theta, due to a vertical component, then we are having it is m v sine theta, because the formula is what? mv square by r. So it is mv sine theta ka square by r. This will come over there. So then we can have this one as qbb sine theta, and it is mv square sine square theta by r square. So v and sine theta, that will cut its one of the power, and we will remain over there with this r square. So how much is the radius of this circular path in which it is going to move? So thus we get over here, this is r is equal to, okay, just a wait, that it is mv square by r, it is not r square in this case. So that's r is equal to mv sine of theta by qb. Okay, this will come over here. So thus we got over here that the radius of that circular path in which this charged particle will move when it is going to enter at an angle. Now let us to look over here that what will be the time period and what will be the frequency over here. So time period, that it is capital T, and time period is what? That time taken to complete one round. So in one round, how much that distance it will cover? It will equal to the circumference, and upon में that speed. नाउ विद वट स्पीड इट इज़ गोइंग टू कंप्लीट द राउंड. ठीक है, जैसे हमारे पास ये क्या कर रहा था, इस तरह से ये जो वर्टिकल सर्कल था उसमें मूव कर रहा था, तो इस वर्टिकल सर्कल के अंदर उसकी वेलोसिटी क्या थी हमारे पास? इट वॉज v sin theta. ड्यू टू ऑफ दिस वेलोसिटी इट वॉज कवरिंग दिस वर्टिकल सर्कल. सो दस वी आर गेटिंग इट इज़ दैट वन कंप्लीट राउंड में जो हमारे पास डिस्टेंस कवर्ड है 2πr, और जो स्पीड थी उसमें दैट इट वॉज v sin theta. So thus we get over here it is 2 pi v sin theta, while the value of this r, so right now we have just calculated the value of r, it is mv sin theta by qb. Okay, this is the value. Now over here sin theta it will cancel with sin, and v is cancelling with this one, so we get it is 2 pi m by qb. Okay, this is same that expression which we are obtaining as it is obtained in that case when it was moving perpendicularly. Okay, तो परपेंडिकुलरली जब ये एंटर होता है उस वक्त भी टाइम पीरियड का फार्मूला सेम था, और जब ये एट एन एंगल पे एंटर होता है तब भी फार्मूला सेम था, ओनली रेडियस का फार्मूला थोड़ा सा चेंज हुआ. ठीक है, Now the next is that related to its frequency. So frequency, number of complete round in 1 second. So as we are known, frequency is the reciprocal of time period. So thus we can interchange these values. So it is qb by 2 pi m. Thus we get over here, it is the frequency with which this charged particle will cover the number of round in 1 second. Okay, so now if we look back again to the diagram, so we will find over here that under the effect of these two component of the velocity, that due to of this v cos theta it is moving along a horizontal direction, while and due to of this v sin theta it is moving in these circular paths. Okay, so therefore that the combined effect is over here, it is the particle is having a helical path that we are talking of about. So whose axis is you will find over here this helical path. Okay, this is what helical path. So we will find that this type of the path, it is helical path. Okay, or so over here this helical path that it is going to move, helix path. So remember that what type of path is moved while the charge is going to enter at an angle, then we should to give the our answer that it is the helix path it moves. Why it moves this helix path? Because and due to of these two component of the velocity. So one is responsible for its horizontal motion, while the other is responsible for that motion along a circular path. Okay, therefore this is going to be our helix path, the combined effect. Now let us to look over here that how much is that distance moved by it in one complete round. तो एक complete round में वो कितना distance पूरा करता है, linear distance. So this is said to be over here pitch. This will be as pitch. So pitch को हम p से denote कर रहे हैं. So thus over here that what is the meaning of this pitch? So pitch means to say that how much distance it is going to cover while in direction of a magnetic field in one complete rotation. ठीक है, तो जो चार्ज पार्टिकल है वो एक complete rotation में उस magnetic field की direction में कितना distance cover करता है. So as we are known with this one, that distance is equal to speed into time. Okay, what the formula we are having for distance? Pitch is what? It is that distance, linear distance. So distance is equal to speed into time. Now we are looking over here, किसकी बात की जा रही है? इन वन रोटेशन. ठीक है, तो रोटेशन के लिए सर्कुलर पाथ आता है. सर्कुलर पाथ में कौन सा कंपोनेंट ऑफ वेलोसिटी था? इट वाज v sin थीटा. ठीक है, तो जो सर्कुलर मोशन है इट इज ड्यू टू v sin थीटा इनटू how much time it was taking for one complete round. So thus we have calculated over here that it is said to be time period. Okay, so this is t, time period, and thus we obtained over here that it is v sin theta, and the value of t from this relation, it is 2 pi m by qb, or either we can write this is over here that pitch is equal to that of 2 pi m v sin theta upon my qb. Okay, this is what, this is that pitch, the linear distance moved over here by that charged particle in one complete rotation. Okay, so that's all from my today's video. Thank you for watching this.